Okay, hello and welcome everyone to the week number 11 of the live interactive session for the course on integrated waste management for a smart city. I am Sedu Vinayagam, a PhD scholar in the civil engineering department at IIT Madras. So let's start with the concepts that were covered in the lectures of week 11. So this week we started off with the continuation of the C&D waste management that we left off in the last week, and then moved on to the e-waste management. Right. So the first lecture was about um, some examples of the different methods that we can use for the management of construction and demolition waste, such as the recycling, reuse, and the disposal methods. And then the second lecture, we continued looking at the disaster debris, which is also one part of the construction and demolition waste, which is coming at the time of natural calamities or other disasters. And so, in particular, we looked at one particular case study of Hurricane Katrina from the US, right? So, how how that disaster debris is more difficult as compared to a construction waste or a demolition waste, because all the different types of or the components are mixed together, right? And it is very difficult to separate them and then process them separately. So that's a difficulty that comes with the disaster debris. So we looked at that in this case study, and then we moved on to the e-waste management, right? So we defined what we mean by e-waste, and then what are the how can we classify this e-waste into different categories, and then with respect to the Indian scenario, what is the scenario with respect to the e-waste in India, right? So how much are we operating, and what are the different, or what is the composition of the e-waste in the Indian scenario. Then we looked at if the environmental and the health hazards, right? If we do not manage the e-waste properly, if we do not handle them properly, then how would affect the environmental health as well as the human health, right? And in the final lecture of this week, we looked at one particular way of managing the e-waste, which is recycling. So in India, how what is the status with respect to the recycling of e-waste, right? So what are the different companies that are out there, and how are they managing to do the recycling in India, right? So that's what we looked at in week 11. So with respect to this, we'll look at some questions. So the first one is, dash is an outcome of a product or a substance that is no longer suited for the intended use. So the options are reuse, waste, disposal, none of the above. So you can type your answer in the chat. So the given definition, what is it for? Is it for reuse, waste, or disposal, or none of them? So we have one answer, option B. Any other answers? Yeah, we have a couple of answers, both saying option, right? So the answer is option B, waste, right? So this is how we define a waste, right? So it is any product or any substance. If it is not useful anymore, then or what it was supposed to be used for. If it cannot serve that purpose anymore, then we call it as waste, right? Because it has lost its usefulness, right? So that is the definition of waste. Whereas disposal are methods of how we would handle the waste, right? Some particular examples of handling the waste. Okay, so question number 2 is, which of the following is the hazard associated with the incineration of e-waste? So option A is polyvinyl chloride present in e-waste generates toxic flue gases. Option B, it creates leachate problem. Option C, it creates groundwater contamination. And option D is none of the above. Okay, so we have two answers for option A. So we'll look at the right one. So it is the right answer is option A. So the polyvinyl chloride present in e-waste generates toxic flue gases, right? So we are talking about one particular method of handling e-waste, which is incineration, right? So which means we are going to burn the e-waste. So what happens when we burn it? So what is the hazard or the problem when we burn the e-waste, right? So options B and C are talking about the leachate and the groundwater contamination. So these issues do not arise when we are doing the incineration, right? So when we dump the e-waste, when we dispose it in a landfill, so that's when the leachate problem and the groundwater contamination can arise, right? It can potentially arise. But when we are looking at incineration, it is going to generate toxic flue gases depending on what is the composition of your e-waste, what is present in the e-waste, right? So depending on that, it will create toxic flue gases. So mainly there will be plastics, so it is going to contain PVCs or the polyvinyl chloride. So that will generate the toxic flue gases, right? So we looked at this in the lecture. So of the different disposal types, so incineration is one of them. So we also have other substances such as the brominated flame retardants, so which can generate the toxic polybrominated dioxins and furans. And in particular, PVCs generate the toxic flue gases. So if we go for other options such as landfilling, so that can lead to soil and the groundwater contamination because of the leaching issues, right? So it can contain hazardous metals which can leach. If we go for recycling, then even in that case also we could end up with some hazardous emissions polluting the water as well as the air, because in the recycling we try to recover some precious metals, and in that case we are releasing the other hazardous content into the environment, right? So those are the other methods and the hazards associated with them, whereas with incineration it is mainly the gases that are released. Okay, so question number three is, which state produces the lowest per capita e-waste in India according to the WEEE assessment study in 2005? Options are Andhra Pradesh, West Bengal, Delhi, and Bihar. Yeah, so we have a couple of answers for option D, Bihar. So yeah, so that is the right answer. So Bihar produces the least amount of e-waste per capita, like per person. If you look at it, so Bihar comes produces the least amount. So this is actually in 2005. The scenario now could be different, right? But according to the study that was conducted in 2005, this was the scenario. So Bihar was the least e-waste producing state in a per capita unit, right? And the highest one was generated by Delhi. And here is a graph. So this is just showing us what is the total amount of e-waste in the country, right? And how is it projected to grow in the years to come, right? So we see that in 2005 around 14 million tons, around 14 lakhs of e-waste was produced, right? And the trend that is projected shows us this is going to be increasing in the years to come, right? And the increase is more than linear, right? It's more like exponential, right? So we are going to generate more and more of this e-waste, and therefore it is necessary that we handle it properly. We have facilities that handle these properly in an environmental friendly manner. Okay, so question number four is expand WEEE. So we have four different expansions given. So the options are waste electronic and electrical equipment, waste electrical and electronic equipment, waste economical and electrical equipment, waste electrical economical equipment. So which is the right expansion for the acronym WEEE? Okay, option B. Okay, we have the answers as option B, and option B is the right one. So WEEE stands for Waste Electrical and Electronic Equipment, right? So it is just another term that we use for e-waste, right? So what does it stand for? What does it describe? It is, so WEEE means any electrical or appliance, electronic appliance that has come to its end of life, or it is discarded by its owner because it is not of any value anymore. But any such equipment which uses some electricity for its for running, so that is classified as the WEEE, right? Once it has reached its end of life or it is damaged and then discarded, so any such equipment that uses electricity is described as this waste electrical and electronic equipment, right? So this is how we describe. This is a term that describes or used to say what is the e-waste. Okay, so question number 5 is solid waste produced during the construction, renovation, or demolition of buildings, roads, bridges, and other artificial structures is called. Options are construction waste, demolition waste, construction and demolition waste, and municipal solid waste. Yeah, so we have a couple of answers. Option C. I think this is a straightforward one, right? So here we are talking about the waste produced in both the construction stage as well as in the demolition stage of any structure. Right, so that means waste will be produced in all these different stages during the construction, renovation, as well as demolition, right? In all these six stages waste will be produced, and the solid waste from these stages is together classified as the construction and demolition waste. So municipal solid waste is separate, right? It's what comes from the households or the residential locations, so that's the municipal solid waste. As construction, demolition, we don't look at them separately, we put them together into the construction and demolition waste. While the waste coming from the construction stage may be much more easier to handle because we have more control on how we segregate and dispose it, whereas the waste that comes from the demolition of buildings, so that can be more difficult to manage because we have lesser control over what is going into the waste, right? So it's because different components will get mixed together, so it will be more difficult, but still we group them together and put it in a single category called the construction demolition waste. Okay, so question number 6 is dash number of electrical and electronic appliances became WEEE in 2010. So the options are 2 billion, 3 billion, 4 billion, and 5 billion. So this is just some facts that were stated in the lecture. So just to show what was the magnitude of the e-waste that we produce. So what do you think? So just if you don't remember, it's fine. You can just take a guess. How many appliances would we have produced as waste? Okay, we have one answer. Option A, 2 billion. Okay, anybody else wants to take a guess? Okay, so the right answer is 3 billion, right? So it's not too far from the answer said as 2 billion. So this is just some facts. So in 2010, as so whatever we classify as WEEE, whatever equipments and electrical appliances that comes under WEEE, so if we it was around 3 billion, right? So that is the magnitude of the waste or the magnitude of the e-waste that we generated. So this is actually in 2010. So if you look at the trend of growth, it is only increasing, right? So in today it would be even more, right? So it is So it is becoming more and more important that we focus on the e-waste and its impacts, right? So a proper management of it is necessary. So this just shows the magnitude of the problem that we are dealing with. So especially in the Indian scenario, we are seeing an exponential growth, right? So our country is now generating more and more e-waste. We are more and more becoming technology oriented, and that is also leading to more and more e-waste being generated. Okay, so question number 7 is, which of the following disease is caused by exposure to beryllium? So the options are brain cancer, neurotoxicity, berylicosis, and cardiac arrest. We have one answer, option C. Any other answers? Okay, so let's take a look at the right answer. So it is option C, berylicosis. So I mean, you could guess it from the word, right? So beryllium causes berylicosis. Okay, so we have a wide variety of metals, especially non-ferrous metals, being used in electrical appliances, right? In our electronic equipment that we use in our daily life. So there are also a wide variety of health hazards that are associated with these metals. So right, so with respect to beryllium, one particular disease that is caused by it is the berylicosis, so which is a disease which affects the lungs, right? And also it is a carcinogen, which means it produces, or it affects our health and produces cancer, right? So that's what we call it as a carcinogen. So there are other metals which causes other issues. For example, neurotoxicity is caused by mainly lead, and silver in excess amounts can cause issues such as cardiac arrest and so on, right? So different metals will lead to different affects us differently. So for beryllium, it is berylicosis. Okay, so question number 8 is, e-waste is segregated into which of the following categories? So the options are printed circuit boards, electronic components, computer peripherals, all of the above. Okay, so we have a couple of answers. Option D. So option D is the right one. So we looked at four different categories in which we could classify the e-waste. So those are the computer and computer peripherals, PCBs, which is the printed circuit boards, and other electronic components. And option 3 is the wires and cables, electrical wires and cables, and the cut wires. And option 4 is any other electronic equipment. So these are the broad four categories in which we could put an e-waste under, right? So the options cover all these cover all these different options that we have listed here. So all of the above is the right category, right answer. Okay, so question number 9 is, which of the following is the major component present in e-waste? So the options are glass, plastic, metals, and cables. Which is the major component? Okay, we have an answer B and C, and then option B. Okay, so the right answer is actually option C, metals, right? So we have the three major ones are the glass, plastic, and metal. But among these, metals constitute the most or the majority of the composition, right? So in the e-waste. Plastic and metal take about 23 and 20%, but it is the metals which is the majority. And now, but the trend is that metals, the use of metals is reducing and the plastic is increasing, but still metals make up the majority of the composition, right? So about 57 percentage, right? So that's why option C is the right answer. Okay, so question number 10 is hydrometallurgical process technique is used for processing of dash waste. The options are construction debris, municipal solid waste, biomedical waste. Option D is e-waste. Yeah, so we have the answers as option D. D is the right answer. So, what is the hydrometallurgical process? So, we use some kind of an aqueous solution, right? So we use that to leach out the metals, so the precious metals that we have in our e-waste. So we use some aqueous solution to leach that out. So that's the core of the hydrometallurgical process. So we use some leachate for separating out the metals from this waste, right? So that is the hydrometallurgical process. Because we are using an aqueous solution, it is called as a hydrometallurgy, right? So that we use only for the e-waste because we want to recover some of the metals such as gold or silver or copper and other metals that are of high value, right? So that's why we use that for e-waste, whereas we don't go for that because in the other wastes we do not see those kinds of materials that we could recover, right? So only for the e-waste we do this hydrometallurgical process. Okay, question 11 is what are the multiple pathways and the receptors needed to be considered for determining the potential beneficial use of industrial waste? So the options are direct human exposure, biodegradability, toxicity, and impact on ecosystems. Okay, we have one answer, options A, C, and D. Any other answers? So this is a multiple select question. So more than one option could be correct. Okay, we have one more answer. Options A and C. Okay, so let's look at the right one. So it is the right options are options A as well as D. Direct human exposure and impact on ecosystems. Right. So those are the different receptors and the pathways that we should take into consideration. So along with that, we should also look at the contamination of groundwater, right? So these are the different aspects that we need to take into consideration before we say whether we want to go for the beneficial use of the industrial waste, whether we want to reuse or the recycle, right? So whether we want to recover anything from this industrial waste. So before we say we will do that, we should look at to what is the how is it going to affect the human health, how is it going to affect the ecosystem, how will it affect the groundwater, right? So when we looked at municipal solid waste, we said that we should minimize uh, the amount of waste that goes to the landfill, right? So the amount that is disposed into the landfill, whereas we should recover as much as we can from through process such as reuse, recycle, waste to energy, and so on, right? So because in when it comes to the municipal waste, we are not dealing with hazardous substances, right? So it is mostly non-hazardous. So in that case, we want to make use of we want to reduce the amount that we are disposing it away, right? Whereas when we are looking at the industrial waste and e-waste, so in these cases, mostly we will have we'll almost in all the cases we will be dealing with hazardous waste, right? So in that case, when we want to do some potential recovery or reuse, we should be aware of the negative effects, right? Because it is more dangerous because we are dealing with hazardous substances. We should also weigh the risks that we are taking when we are trying to recover some value from it, right? So therefore we should consider the direct human exposure and also the impact on the ecosystem, right? So because we are not going to mostly deal with biodegradability or the toxicity, because these are known to be hazardous and they are not going to contain organic substances, so we are not worried about that. But the direct exposure, when because the people who are going to be working on this processes, they will be directly exposed to these heavy metals and other fumes, right? So we need to take into consideration of those effects before we decide whether we want to go for this beneficial reuse or not. Okay, so question 12 is with respect to the hydrometallurgical process that we saw earlier. So, which of the following are the different leaching methods for the precious metals recovery using the hydrometallurgical processing technique? So, the options are cyanide leaching, thiourea leaching, thiosulfate leaching, and shredding of e-waste. Okay, we have an answer. The options A, B, C. Okay, we have another answer. Options B and C. Okay, so let's look at the right answer. It is options A, B, and C, right? So all three. So as I said earlier, in a hydrometallurgical process, we are going to use some kind of an aqueous solution to do the leaching, right? So we have some ore or some concentrate from which we want to separate out one particular metal, right? So in that case, we are going for this hydrometallurgical process. So we could use cyanide or halide, thiourea, or thiosulfate. So all these are different aqueous solutions that can be used for this leaching, right? So we want to leach out the metal from this from some concentrate that contains some impurities, right? So that's what this hydrometallurgical process is. All these three uh, are different methods that we could adopt, right? Whereas shredding of e-waste, it is not going to help us in metal recovery, right? It is just method to reduce the size, right? So we want to make it smaller for to make it easier for further processing, right? So shredding is not going to help us in a precious metal recovery, and it is also not an hydrometallurgical process. Okay, so question number 13 is, which of the following statements are true? Options are: landfilling of e-waste can lead to groundwater contamination, human health is not affected by e-waste, burning of cathode ray tube emits toxic fumes, 10% of e-waste produced in India is recycled. So what are the correct statements listed here? Okay, we have one answer, options A and C. Okay, any other answers? Okay, so we have another answer which is also A and C. So both A and C are correct, right? So those are true statements. So as I said earlier, e-waste can contain both hazardous as well as non-hazardous material, right? So for example, say let us take plastic itself, right? So if you are just going to dump it into a landfill, that's not going to that's not going to affect, because it is going to remain as such. So it's not going to leach or anything. But when you are going to incinerate it, then we saw that PVC will produce toxic fumes, right? So toxic flue gases and fumes. So depending on how you are handled, it's going to vary. But in other cases, there are certain elements that are going to be hazardous, right? So whichever one you are using, it's going to be remain hazardous. For example, our circuit board. So where we use lead for soldering. So lead is a heavy metal, right? So it is an hazardous substance. So that's going to affect your environment, right? So it both hazardous as well as non-hazardous materials are there, and depending on how you are going to handle it, that can lead to affecting your human health as well as the environment. So landfilling of e-waste can lead to groundwater contamination. So yes, so because there are heavy metals, so if we do not handle it properly, if we do not use a lined landfill, when the e-waste is containing hazardous material, so it can lead to leaching, and it can affect the groundwater and contaminate it, right? So that is a correct statement. Human health is not affected by e-waste, which is false. So for obvious reasons, as we are talking about, so because it is having the potential to contaminate the environment, it can ultimately affect the human health as well. So that is a false statement. So burning of cathode ray tube emits toxic fumes. Yes, because cathode ray tubes contain heavy metal. So if you burn it, so that can produce toxic fumes. So that is true. And option D is 10% of e-waste produced in India is recycled. So that is false, because the amount of e-waste reduced recycled in India is very very low, right? Under 5% or 4% is what we are actually is actually what is being recycled in the Indian context, right? So 10% is a very large number. So we are not there yet. So option D is false, right? So question number, yeah, so this is from the lecture material, right? So landfilling of e-waste, it can lead to leaching, right? So we looked at one example, lead, and that can lead to groundwater contamination. So CRT, when we crush it, burn it, it will emit toxic fumes. And with respect to recycling, so not even 4%, right? It's barely 4% that we are going. That is going for the recycling process, right? So that is the current state. Okay, so question 14 is, what are the different steps followed by a company in the management of e-waste recycling? So the options are collection, dismantling, treatment of waste, and recycle. So our e-waste recycling company, so which are these steps will be undertaken by that particular company? A generic e-waste recycler. Okay, we have one answer, which is all the options A, B, C, D. Okay, so we have a couple of answers which say all the four options A, B, C, D. So the right answer is only A, B, and D. Right. So when collection, dismantling, and recycling, not the treatment of waste. So when we in a generic case, so collection is important, right? So we need to collect. We need to we need the material to work with, right? So collection is the first step. Then it needs to be transported to where the facility is. So once we reach the facility, we need to segregate it into the different components, right? So, like the plastic separately, metal separately, and so on. And also then we go for dismantling. If we have say a CPU, we want to dismantle and then separate out the different components, right? So, and finally we go for the recycling, right? So during this recycling, we try to recover as much as we can, whatever are the products that we can. So all the plastics that will definitely be recycled. So the wires, they can be recycled and so on. And whatever are the hazardous materials that are remaining. So it's a very small fraction of the waste that we are of the e-waste that we are collecting that is going to be hazardous, and that will not going to go through the recycling process. It will be sent uh, to whatever is the facility that can handle this hazardous waste, right? So it is not part of the e-waste recycling stream or the e-waste recycling process, right? So the hazardous material will be separated out and it will be sent and transported to different service who can handle that, right? So as a part of the e-waste recycling, so a company is only going to look at collection, transportation, and then final up to the recycling stage, right? So in the recycling stage, we try to separate out the hazardous part and only try to recover whatever we can from the rest of it, right? So which is it can be up to 98% because the hazardous component is lesser, but it can have a very huge impact if we do not handle it. But the percentage wise, it is very small and it is not treated in a e-waste recycling company. Okay, so question number 15. Which of the following statements are true regarding e-waste? So options are, there are no regulations for e-waste management in India. E-waste can be both hazardous and non-hazardous. Landfilling of e-waste does not create any problem. Threat to human health if not managed properly. Okay, options B and D is one answer. Okay, we have B and D as another answer. Okay, one more answer, which is only option B. Okay, so the right answer is actually both options B as well as D. Right, so we almost looked at all these different statements in our previous questions, right? We discussed about these except for option A, which says there are no regulations for e-waste management in India. That is false because we do have our rules with respect to e-waste management. So we do have regulations for how we have to manage the e-waste in the country. So about in I think 2016, at the same time as the CND waste rules as well as the municipal solid waste rules came. So e-waste management rules also has been given, so we do have regulations. So option A is false. Option B, as I said earlier, both e-waste can contain both hazardous as well as non-hazardous components, right? So it can be both. So option B is correct. Option C, landfilling of e-waste does not create any problem. So that is false because we saw that it has the potential to leach the heavy metals and potentially contaminate the groundwater, and even the soil also could be contaminated, right? So landfilling does create a problem. And option D is threat to human health if not managed properly. Yes, that is a true statement. If we do not handle it properly, it will ultimately affect the human health, right? Because of its hazardous nature. Okay, so options B and D are the correct statements. Okay, so that concludes the session for this week. If you have any questions, you can ask. Right, so we have one more week of lectures, right? So we have completed 11 weeks, so the 12th week of lecture is remaining. So therefore we'll have one more session next Friday, right? So that will be our last session, right? So if you have any questions, please feel free to ask. Otherwise we'll wind up the session. Okay, thank you all. If you have no questions, we'll close the session. Thank you.